welcome to our ratio and proportions lecture. And we just have the one slide deck, but there is a lot of information contained in this, so buckle in. So a ratio, the definition of a ratio is the comparison of two quantities that have the same units. Okay, so remember, they have to have the same units, and remember that definition. So you can write it. A fraction is actually just a way to state a ratio. A over B, A is to B. You can separate them with a colon. We call that ratio notation. Put a colon between the two numbers. And as I've said a couple of times in the lead up to this, you could also say it as A is to B, and that's the same thing as A colon B, or the fraction A over B. Three different ways of writing a ratio. Two numbers with the same units. So let's start with something you actually already know how to do. We're going to express the ratio of 16 to 48 in lowest terms. So I'm going to rewrite this as a fraction, just because it's something we've done before, and that should look pretty familiar. So now we start simplifying. Okay, we'll take the 2's out. 2 goes into 16 8 times. 2 goes into 48 24 times. Let's divide that, both the top and the bottom, by 4. 4 goes into 8 twice. 4 goes into 24 6 times. We're still not simplified. So 2 goes into itself once, and 2 goes into 6 3 times. So we have the fraction or ratio of 1 to 3, and rewrite it in ratio notation as 16. The ratio 16 to 48 is the same as the ratio 1 to 3. Okay. So exact same thing, that's just more examples, but you're essentially just simplifying fractions. And if you have got your fraction simplification on lockdown, you also have your ratio simplification ready to go. If anyone doesn't, please let me know, and I'd be happy to do some more examples for you. So what I've shown you so far is the ratio of two whole numbers, but you can also have the ratio of two fractions. So you can have the ratio 2/3 to 4/9. Okay, a little confusing at first. So how would we express this ratio? Okay, so let's set this up as a fraction over a fraction, and this should start making sense pretty soon once I do a little manipulation of those fractions. So let's rewrite this as 2/3 over 4/9. Okay, that's still a little sketchy, right? So let's write it as 2/3 divided by 4/9. Now this should start snapping into focus. To solve that, we need to multiply by the inverse of the second term. So let's rewrite this as 2/3 times 9/4. And now we're ready to solve it. So 2 times 9 is 18. 3 times 4 is 12. Now let's simplify this. 6 goes into 18 3 times. 6 goes into 12 twice. So the proportion of 2/3 to 4/9 is 3 to 2. So 2/3 is to 4/9 as 3 is to 2. So you can see I can kind of break these down into little bite-sized pieces, and then at some point you end up with something that starts looking familiar, and then you're home free. So let's do one more of those. Sometimes this can be a little mind-bending to people. So let's take a look at another example. So 3/4 to 1/4, or we write it as 3/4 to 1/4. Okay. And we'll rewrite it as 3/4 divided by 1/4. Then we'll solve that expression by 3/4 multiplying by the inverse of the second term, which is 4/1. And we have 3 times 4, which is 12, and 4 times 1, which is 4. And then 4, of course, goes into 12 exactly 3 times. So the ratio is 3 to 1. So 1/4 is to 3/4 as 3 is to 1, which if you kind of think about it, makes sense. There are 3 1/4 in 3/4. Okay. Did everyone follow along with those okay, or would you like me to work another example? Everything's good? Okay, I'll assume everything's good unless I hear differently. Okay, so we've manipulated fractions, but as we learned from yesterday's lecture, decimals can also be written as fractions. So if you have something like 0.08 to 0.12, let's convert the first decimal into tenths, hundredths. That is 8/100ths. Ratio of 8/100ths to 12/100ths. And now we can do just like we did with the fractions that we just solved. 8/100ths. And I'm going to skip a step here. If anyone doesn't follow along, let me know. I'm going to go straight to 8/100ths divided by 12/100ths. Okay. And then I am going to write down 8/100ths times 100 over 12. I will get 800 over 1200. Take 100 out of both of those to get down to 8/12. Simplify it even further. 4 goes into 8 twice, and 12 3 times, which gives us the ratio of 2 to 3. So the ratio of 0.18 to 0.12 is 2 to 3, is how we would answer that verbally. So let's work the ratio of 1.2 to 10. Oh, yes, Taylor.
So just making sure for the homework, are we listing it as 2 basic to 3, or would we do it as like the division sign with like the slash?
The technically the correct way to answer those questions as they are on the homework is in ratio form. However, if you have the right numbers and you have them as a fraction, I understand that you know what's going on. So either one works for me. So yeah, your choice. You could use either or both. Okay, so let's look at another one. So just like we saw yesterday, 1.2 can be expressed as 1 2/10. Remember? So 1 2/10 is to 10. So first thing I'm going to do is to convert this mixed number into an improper fraction. So 10 times 1 is 10, plus 2 is 12/10 at fraction, and then 10 over 1. Okay, remember 10 divided by 1 is the same as 10. So let's go ahead and solve this. So 12/10 divided by 10/1, 10 over 1. Solve that. by multiplying by the inverse, 1/10. So we have 12 1/100ths. Simplify that fraction. 3 goes into 12 4 times. 3, no, that is not the right way. 4 goes into 12 3 times. 4 goes into 125 times. So the answer is what is 1.2 to 10? The answer is the ratio 3:25. Or like I just said, just told Taylor, 3/25 is acceptable to me as well. Okay, so a little review from what we did yesterday, combining it with some concepts that we are becoming familiar with tonight. Mixed number ratios, we've already run through those, but you know what? Let's just do that one more time with just mixed numbers instead of having to convert the decimals to 3 1/3. So we want the ratio of 1 2/3 to 3 1/3. First step, let's get our improper fractions. That's 3 times 1, that's 5/3 to 10/3. We are going to divide 5/3 by 10/3. I'm going to go up here, utilize this side. So 5/3 times 3/10 is going to give us 15/30, or 1/2, or 1/2. Which, like I said, you can think about it. Basically, there are two 1 2/3 in 3 1/3. And if you took out a measuring cup and measured out 1 2/3 twice, you would have 3 1/3 cups of whatever it was that you measured out. Oh, those are ratios. That is the first concept we're covering tonight. The second concept we're going to cover is proportions. And a proportion is, and if you remember, a ratio is two numbers with the same units. So a proportion is two ratios that are equivalent to one another. So a proportion is a group of four numbers that have the same units and they're equivalent to one another. So, and you designate that they are equivalent by our old friend, the equal sign. That's all that means. That 1/2 is equal to something with a numerator of 2 and a denominator of 4. So those have the same proportional relation to one another. And we can use this concept to solve for an unknown. But before we get to that, we need to make sure that everyone understands how you would solve a line that looks a little something like that. And it gives you the answer right there. A little screenshot. You want to divide both sides by 7. So I'm just going to do this manually. 7/7 is the same as 1, so I just cross those out because 1 times anything is the anything. So 1 times y is y. I'll just rewrite that there. And 42 divided by 7 is 6. So we have solved for the unknown, in this case, y. And you're going to be using this idea, this algebraic idea, in just a couple moments. That's what I call, when you hear me saying solve for the unknown, that's exactly what I'm asking you to do. So two ratios that are equal is a proportion if A and B are and C and D are equal ratios, then A and B is equal to C and D, and that term is called a proportion. And we can use properties of proportions to solve for unknowns. So here is a term that has a ratio on one side and its proportional ratio on the other side. However, we have an unknown. And you know what? Let me designate that with a different color. There we go. All right. So this is the mantra. This is the quick and dirty way to take care of these when you see something like this that I want you to repeat to yourself and learn. You want to cross multiply and solve for the unknown. That's cross multiply and solve for the unknown. And by that, I mean I'm going to multiply the denominator times the numerator on that side of the equal sign, the denominator and the numerator on this side of the equal sign. So 2 times x is 2x, right? And 3 times 4 is 12. And now we solve for x by dividing both sides by 2. So the 2 goes away. We are left with x is equal to 6. Okay, and if you're not sure and you want to check your work, go back to your original equation and plug in 6 for x and simplify. So 2 goes into 4 twice, 2 goes into 3 times, and there we go. We have 2/3 being equal to that initial ratio of 2/3. And another way of saying it as 2 is to 3 as 4 is to x would be a way of saying that in English. Okay, cross multiply, solve for the unknown. So let's do this some more. So n, which is our unknown, is to 3 as the decimal 0.4 is to 8. All right, we're going to cross multiply and get 8 times n is the same as 3 times 0.4 is 1.2. Right here. Divide both sides by 8, and we will get n equal to 1.2 divided by 8. 0.15. So n is the equivalent to 0.15. If it's anything else, then those two terms are not proportional by definition. Okay. Okay, so I would like you guys to give me an answer for the first one. 3 is to 5 and 6 is to x. So work through that one for me. Cross multiply, solve for x, or solve for the unknown, whatever it may be. Yes, Taylor.
I got x equals 10.
Okay. Let's see. Does anyone else have an answer? Who was that? Someone else raise their hand?
Same answer.
Okay. All right. Let's see what we got. So cross multiply. 3 times x is 3x. 5 times 6 is 30, divide both sides by 3, x is equal to 10. Very good. I think you got it. And that second one can be, those other two are more complicated than anything that we're going to see either on your homework or on the final. But we can circle back to those if you're really raring to do a little extra credit. No problem solving those. But let's just move forward. Okay, so let's do a dreaded story problem. So we have a woman who drives her car 270 miles in 6 hours. So let me write down those what we're known. We got 270 miles in 6 hours. And if she continues at the same rate, which we don't know, how far will she travel in 10 hours? So we know that the other unknown, or the other known, is 10 hours. What we don't know is how many miles that is going to be. So our unknown is x, and we know they're proportional. So let's set up this ratio, or these ratios in a proportion. Okay. Okay. So we know that she went 6 hours, was in 270 miles in 6 hours. And then you have to make sure, since we have miles down here, we know that x is our unknown. So that's the number of miles. So we're keeping those, keeping our units the same. And the other thing we do know is that is 10 hours. So the hours are across from the hours, the miles are across from the miles. Now, cross multiply and solve for the unknown. 6x is equal to 2,700. Divide by 6. X is going to be equal to 2,700 divided by 6, or 450 miles. So after 10 hours, she will have gone 450 miles. Okay, did everyone follow along with that? I know it was a story problem, but once you write down the numbers and set up your equation, and then it kind of just all fits together. Kind of like a well-written piece of music. Okay. I would like you guys to try the following story problem, okay? And let's see, I think I have someone who is not muted. Yeah, check and hit the mute button for me. Thank you very much. So, a softball player gets 8 hits in the first 18 games. And if the player continues at the same rate, how many hits will she have in 45 games? And I'll tell you, in the spirit of the Mariners not being absolutely terrible, I will call an audible and say, if a baseball player gets that many hits, how many hits will he have after 45 games? Okay, has someone come up with a hit rate for this person? Okay, Derek, what'd you get?
101.25.
Okay. Has anyone else gotten a solution? Okay, So I'll work through it, and you guys can keep working on it and see if we have arrived at the right answer or not. So we have a person, a mariner, 8 hits, call him Kyle Seager. 8 hits in 18 games. If this player continues to hit at the same rate, how many hits will there be after 45 games? So we know the other unknown is 45 games. What we don't know is the X number of hits after 45 games. So we know the key was that they're hitting at the same rate, so we have our proportion. So let's set this up. So we have 8 hits in 18 games. So we have X hits in 45 games, right? Hits across from hits, games across from games. Now let's cross multiply. 45 times 8 and 18 times X. I know 18 times X is 18X. And then 45 times 8, that'll be 360. Now, to solve for X, we need to divide both sides by 18. So 360 divided by 18 will give us 20 hits after 45 games. Okay. Does that make sense? And Derek, did you see where
I put the 45 in the numerator.
Yeah, so that is the key to the proportion. That is a very, very important point. You want to make sure that your units are across from one another. If you flip them, then you no longer have that proportional relationship. You have to have your units across from one another, or you're going to run into exactly those issues. So that is the key thing. Let's look at, let me see, what do I have? Let's do one more story problem. So I'll work through one more that's more kind of medical. So I'll apply a little more to the world that you're entering here. So you have a solution that contains 4 milliliters of alcohol and 20 milliliters of water. So I'm going to write down that as 4 milliliters of, I'm going to write this as ethanol in this case, and 20 milliliters of water, H2O. If another solution is going to have the same ratio of milliliters of alcohol to milliliters of water and must contain 20 milliliters of water, how much alcohol should it contain? So our mystery is going to be milliliters of alcohol, right? Ethanol. And we know that the second solution has 25 milliliters of H2O, as stated. Okay, so let's set this up. We have 4, and I'm just going to put ethanol, is to 20 of water as, or equal to, X of ethanol as 25 of water. You say, double check. Ethanol, ethanol, water, water. They are proportional. So it's supposed to be an arrow. Cross multiply, 25 times 4 is 100. 20 times X is 20X. Solving for X, I need to divide both sides by 20. So X is equal to 5 milliliters of ethanol in the second solution. It has the same ratio as the first solution. Okay, and that is it for problem working. And if you remember back to the very beginning of the lecture, a ratio is a blank of something with the blank units. Let's go all the way back and tie this together. A ratio is, oh, where did it go? So, sorry about that. So it is a portion of with the same units, obviously, and kind of tucked out away in your memory bank there, in case it shows up again. Okay.